Hi everyone, today we will learn about parity generator and parity checker which are commonly used for error detection during data transmission. First, let's understand the parity generator. A parity generator produces a single parity bit based on the input data bit to enable error detection. There are two types of parity. Even parity, in this the total number of ones including both the data bits and the parity bit is always even. And odd parity, in this the total number of ones including both the data bits and the parity bits is always odd. Now let's look at the even parity generator. For an even parity generator, the parity bit is generated by performing an XOR operation on all the data bits. If the data has an odd number of ones, the parity bit is set to 1. And if the data has an even number of ones, the parity bit is set to 0. Now let's see its system Verilog implementation. Here the parity bit is simply generated by applying the XOR reduction operator to the input data bits. Now let's move to the odd parity generator. For an odd parity generator, we first compute the XOR of all input bits, then we invert the result. Here, if the data has an even number of ones, the parity bit is set to 1. And if the data has an odd number of ones, the parity bit is set to 0. Now let's look at its system Verilog implementation. Here we see that the parity bit is generated by inverting the XOR reduction of the input data. Now this was the parity generator. Now let's look into the parity checker. A parity checker verifies whether the received data along with the received parity is correct or corrupted. The input are the received data bit and the received parity bit, whereas the output is the error signal which indicates whether an error is present or not. First, let's see the even parity checker. For an even parity checker, all the received data bit and the received parity bit are XORed together. If the total number of ones, including the parity bit, is even, the XOR result becomes 0, indicating that no error has occurred. If the total number of ones is odd, the XOR result becomes 1, indicating an error has occurred. Now let's look at its implementation. Here we determine the error condition by XORing all the received data bit along with the parity bit. Similarly, let's look at the odd parity checker. In an odd parity checker, if the total number of ones including the parity bit is odd, the received data is considered valid and no error is detected. Or if the total number of 1 is even, an error is detected. Let's see its implementation. Here the error signal is generated using the XNOR reduction operator on the received data bit and the parity bit. So to conclude, parity generator and parity checker provides a simple and efficient mechanism for detecting transmission errors in digital communication system. They are widely used because of their simplicity and low hardware cost. However, they cannot identify the exact error location. Thank you for watching and see you in the next video.